One-step inequality word problems. This is going to be fun. Remember this table that I gave you guys a while ago? Well, it's going to be your friend now. If you don't have it or you can't find those notes, make sure you copy this thing down again because it will be useful. Moving on. I have a couple sentences here and I want you to write an inequality from each sentence. Now, be careful. Make sure to read the directions on these because sometimes I want you to solve them, sometimes I don't. Sometimes I want you to solve them but not graph them. So make sure you read them. This one says, write an inequality from the sentence. That's it. So the sum, you got to remember what sum means, and it's the answer to an addition problem of 8 and a number. The number will be our variable. Less than is this and 15. So right there, I just got to rearrange this plus and the x. X plus 8 is less than 15. Then we have product. Product is the answer to a multiplication problem of 11 and a number, there's our variable, is greater than 33. Okay? So product, again, is multiplication. So it looks like x and x, very confusing. So multiplication here. All right, is 11. X is greater than 33. So that's part of what you're going to have to be able to do. I want you to try these three on your own, please. Okay, a number divided by -3 is less than 6. So a number divided by -3, remember fraction shows division, is less than 6. The next one, the difference of a number and 12 is less than or equal to 13. So the difference of a number and 12 is less than or equal to 13. Now, when you're talking about difference and quotients, and they have it listed like this of a number and, whatever is listed first here, a number, that's what's going to be written first. So if it was the quotient of a number and, then x would be up in the top, okay? Just to kind of help you with problems like that. And then the last one, a number plus 20 is less than or equal to -10. So a number plus 20 is less than or equal to -10. Okay, well that's nice. But now let's solve them too. Okay, so here, write it from the sentence, then solve it. So go ahead and try, oh, you know what, I'll do the first one, you do the second one. How about that? So here, a number minus 9 is greater than or equal to -7. A number minus 9 is greater than or equal to -7. I'm going to solve this by adding 9 to both sides, and x is greater than or equal to 2. So I come to my number line, there's 2, 4, 6, 0, -2, and it's greater than or equal to, so it's going to be filled in, and it's going to point to the right. For my check step, I'm going to use the original inequality. X minus 9 is greater than or equal to -7. I'm going to pick something that satisfies it, and it has to be greater than or equal to 2. So I could use 2 here, or I could pick something that would make the math a little nicer and I don't deal with the negatives. I'll go up to 10. 10 minus 9 is greater than or equal to -7. 1 is greater than or equal to -7, and it works. Okay, cool. You try the next one, my friends. Okay, a number divided by 10 is greater than 2.5. A number divided by 10 is greater than 2.5. Now, hopefully, you weren't looking at going, but you need to have decimals in there. What does it matter? You can use a calculator, okay? Multiply both sides by 10. And x is greater than 25. So come down here, 25, 20, wow, what's going on with my pen? 27, 29, sorry about that, that's really funny. 23, 21. So it's greater than 25. That means it's gonna, oops, it's gonna be an open dot. I'm still thrown off by those little itty bitty numbers. Open dots, it's greater than, it doesn't, not greater than or equal to, and it's going to point to the right. For my check step, I'm going to use the original inequality, x over 10 is greater than 2.5, and I'm going to pick a number then that's greater than, I have to pick a number that's greater than 25 for my solution. So I'm going to go and pick one that's divisible by 10 to make the math easier, and 30 right here would work out nice. So 30 over 10 greater than 2.5. 3 is greater than 2.5, and it works. All right, now let's try some word problems because that's fun. Right here. A weightlifter's maximum amount he can lift is 300 pounds. Write and solve an inequality to find the number of 50-pound weights he can possibly lift. I want you to pause this and try this on your own, please. Okay, 50-pound weights. So in other words, 50 pounds each, 50 times the number that you have would have to be less than or equal to that 300 pounds. So 50x less than or equal to the maximum of 300 pounds. So divide both sides by 50, and x is less than or equal to 6. So in other words, 6 of the 50-pound weights is what he could lift. So I'll come down here, 6, 8, 10, 4, 2, and it's less than or equal to, so it'll be filled in. It's going to point to the left. And my check, I have 50x less than or equal to 300. I have to pick something that is less than or equal to 6. So why not pick something that makes the math easy? 2 is on my solution. 50 times 2 is less than or equal to 300. 100 is less than or equal to 300, and it works. Okay? Now, the last one, a little more fun. You purchase a t-shirt for $8.95. Then spot a pair of jeans you would like. So, you have a budget, though, of $25. Write and solve an inequality to find the amount of money you could spend on the pants. Okay, see if you can solve that. This is one where the old let statement is very helpful. Let x equal the max cost of the pants. Now, the shirt is $8.95. The shirt and the pants together have to be less than or equal to your budget of $25. So x plus 8.95 less than or equal to $25. Now I know some of you are thinking, what about tax? I know, let's assume that we are in a tax-free state. Or it's a tax-free holiday. I know those are both funny, but let's just assume that's the case. Then what we do is subtract $8.95 from both sides. And x is less than or equal to $16.05. Now, for the number line, this is something that always gets kids. They're like, well, how do I put this on the number line? You have some choices. You can come down here and say this is 16, and then a 16.05 would be like right there. Or you could say this is 16.05 right here. And then what I'm doing is when I count up, I'm going to go 18.05. I'm just counting by the same increment. I don't really care how you do it, like as long as you are consistent. That is what I care about. So less than or equal to, so it's going to be filled in. It's going to point to the left. For my check step, I'm going to use the original inequality. X plus 8.95 is less than or equal to 25. I need to pick a number that satisfies the inequality, so something that's smaller than or equal to 1605. Well, again, I'm all about making the math easy, and I see that 10 would work here. So 10 plus 8.95 is less than or equal to 25. And I have 1895 is less than or equal to 25. And it works. Now, again, the one thing I didn't do in the previous problem, but I should have, and I'm definitely going to do here, is make sure to answer the word problem appropriately. So, the maximum price of the pants is $16.05. Okay? Remember that when it's a word problem, you should answer it in a sentence when you're done. Okay? That is all. Goodbye.